So today our topic is ambiguous grammar. Ambiguous grammar. So it is a CFG. A CFG is said to be ambiguous grammar if there exists more than one derivation trees for the given input string, or more than one, or we can say the other definition is more than one leftmost derivation. More than one leftmost derivation. Hope you know the what is leftmost derivation. We also called it LMD. Or more than one RMD, rightmost derivation. Most derivation. There is no standard method to check ambiguity. We have to do it by practice, hit and trial method. So there is no standard method to check ambiguity. We have to do it. Sorry for my handwriting. We have to do it by practice or hit and trial method. So what is the problem with ambiguity? So the problem with ambiguity is precedence of operator is violated. So in ambiguous grammar, precedence of operator is violated. Operator is violated means not respected. So ambiguous grammar, a CFG is a context-free grammar, is said to be ambiguous grammar if there exists more than one derivation trees or parse trees for the given input string, or more than one leftmost derivation. Leftmost derivation means in leftmost derivation input scanned, input is scanned and replaced with the production rule from left to right. For example, we have grammar s plus s and s derives s minus s and s derives a, s derives b, s derives c. We can also write this expression like that: s derives s plus s, s derives s minus s, s derives a, b or c. S is variable, non-terminal, and a is terminal, and we have to generate input a minus b plus c. So in LMD our expression is x plus s. So the leftmost symbol on the left hand side of the production rule is this s. So s is expanded as our next expression is s derives s minus s, s minus s, and this s is as it is. Now s derives leftmost is this s, and this is a, and rest is same. And now this is terminal. Now we cannot expand this. Now this is leftmost b as it is. Now a minus b plus c. So we generate our input string as we have given. So for this parse tree is s derives s plus s, s derives s minus s, and this s is a, this is b, this is c, and top to bottom, left to right, this and this. So a minus b plus c, and this string is this a minus b plus c. This is LMT, means leftmost derivation. Rightmost derivation is the vice versa of this LMD. In LMD we scan input and replace it with production rule from left to right, but in RMD it is replaced from right to left. In RMD input is scanned and replaced with production rule from right to left. Take the same example: s derives s plus s, s derives s minus s, and b c. RMD rightmost derivation will be rightmost derivation. First we write this rightmost. What is the rightmost? The right and the end. This derives s. So we have to generate the string a minus b plus c, a minus. So we take first minus because it is rightmost derivation. Let us see what will happen. This s minus s, in this s plus s. So as it is we have to generate a minus b plus c, same as we write here, s minus s, and this S will be C. S minus B plus C, and derives A minus B plus C. Two more examples of this and you will get this concept. Now parse tree we are for, and RMD we take right on the right side. S derives S minus S right hand side, S plus S in the terminal. Top to bottom, A minus B plus C minus B plus. So this is the RMD and this is LMD. So it is all about the today. Let's meet in another lecture. Till then, thank you. Our topic was ambiguous grammar. So ambiguous grammar is a CFG, context-free grammar, is said to be ambiguous grammar if there exists more than one derivation trees for the given input string, more than one LMD or more than one RMD. There is no standard method to check ambiguity. We have to do it by practice, hit and trial method. The problem with ambiguity is precedence of operator is violated, as is shown in this example. What is precedence? Precedence is same from left to right associativity. What if we put A plus B into A plus B into C? So what is precedence? B is the precedence, and in here we get the wrong answer. If we evaluate this, put the value of A, this we will see this in other lectures. So our topic was CFG. Now the CFG is our ambiguous grammar is a CFG if there exists more than one derivation tree for a given input string. Let us see what is the example. We have E derives E derives E plus E into E slash ID. We have to derive, and the input string is ID plus ID into ID. First we check LMD. Our question E into E derives E plus E, leftmost derivative, this ID plus E into E, ID plus E derives ID into E, step by step, one by one, ID plus ID into ID, and the parse tree for this parse tree will be E. This is leftmost derivation, E plus E, left this. So here leftmost derivation, put this ID. This is terminated. Sorry, this is RMD, rightmost derivative, the rightmost derivation. So for this we have to generate ID plus ID into ID. First E plus E, and then E into E. This extends to ID. This is parse tree 1. ID plus ID into ID. This is one derivation. So we have to prove, so we have to check whether it is ambiguous grammar or not. There is not any method available. We have to check it by hit and trial method. So we now left LMD. E derives E into E. E plus E into E. E extends to E plus E. ID plus E into E. ID plus ID into E. And this gives ID plus ID into ID. Now we get the string, our string, and the parse tree true is E into E, leftmost derivative, E plus E, and this extends to ID from top to bottom and left to right. It extends to it, and this is the end. Right ID. Leaf node, we have to check the leaf node ID terminal, and this is the terminal into terminal to ID. Check the least symbol and write it here. So this is the parse tree, and our given, therefore given grammar is ambiguous. Since we have more than one parse tree possible, therefore the grammar is ambiguous. Ambiguous in the sense, if we have two parse tree possible, then parsers will get confused about which one to generate. As you see, we have two parse tree, or which one is correct. In that case, all the parse tree are showing output is same, but the evaluation is different. What does that mean? We have parse tree 1, ID plus ID into ID. So we have input 1 plus 5 into 3. So what does it generate? Parse tree 1 generated 16. Parse tree 1 generated 16. 5 3s are 15 plus 1 16. It generates 16. But in parse tree 2, it generates 1 plus 5 into 3. 5 ones are 5. 5 3s are 15. So in parse tree 2, it generates 1 plus 5. Sorry, this is plus 1 plus 5 is 6. And 6 into, what is there? 3. 6 into 3 is equal to 18. So there is ambiguity, and parser does not allow ambiguous except one, that is operator precedence parser. So these are the pointers of if two parsers are generated, the output is same but the evaluation is different. So I am sorry for my handwriting. If you don't understand any word, then comment. Maybe I can make a different video on this. This is, it doesn't allow ambiguous grammar except of one, operator precedence parser. We will discuss this in another video, and in the next session I will discuss the problem on the basis of this ambiguous grammar. So we will meet in the another class. Till then, bye.